Good evening, everyone. I am Khushi Jiravla. On behalf of my NGO, SSERD, I would like to welcome and thank all of you for joining us today in our fourth lecture series on satellite and applications. I'm very certain that everyone present here are very happy because we will be talking about a great introduction to key principles of satellites and will help in getting the deeper knowledge on SATCOM and what future holds for us. Ha- Having you all here gives me an idea that all are very excited and enthusiastic about the topic, and that makes us more excited. However, who do not know about SSERD, Society for Space Education, Research and Development is an international organization dedicated to promoting and creating awareness about space science. Through our outreach program, we will have planned all kinds of events for audience from all age groups. Our key aim is to update the community with latest news and encourage them to be part of a space revolution which has already started. Before calling our presenter, I want to express my gratitude towards our sponsors, Genex Space, Samarth Academy, and D Space. To know all about them, you would see about them in their respective websites. I appreciate the participants, without which the energy of this webinar wouldn't be a great success. The space industry is developing and delivering benefits that tie into our immediate needs and properties here on Earth. For example, medical and material research, also satellite communication. To talk more on this topic, it is my pleasure to call Speaker of the Day, a rare gem and a space nerd, Shujoy Sridhar. Sujoy Sridhar is the co-founder and chairman of Society for Space Education, Research and Development. Having a work experience at HAL, Air India, and the former CTO of Obro Solutions, a Delhi-based real estate startup, he has a unique talent to develop innovative ideas and bring them to life, primarily focused on aerospace and STEM education worldwide. With having reached more than 20,000 students throughout various space programs, Sujay is dedicating his time to Genex Space as managing director and CEO, focusing on providing space education and career guidance for schools and university level students. If I go on, the day would not be enough to tell about him, but due to the excitement of participants to hear from Sujay Sridhar, I would like to hand over the session to Sujay.
Hi, good evening, everyone. So, am I audible, Kushi? Hello, am I audible? Hello. Okay, I'm assuming that I'm audible. One second. Yes. Okay. Awesome. Okay. Great. So today's topic is satellites. It's one of the interesting topics I have. Thank you, Kushi, for introducing me. And so excited that I'm talking to all of you here. And okay, let me quickly share my screen. Okay. Okay. So today's topic is about satellites, and I'm going to talk a bit of introduction, and then we are going to say how a satellite works, and then how it is helping us in our day-to-day life. Okay. Okay. Awesome. So I'm assuming that my screen is visible. Okay, so let's start off with a question. So when I say space, there are certain things which comes to your mind, right? And these are few things. One is rockets, one is astronauts, and satellites. These are the things which generally comes to people's mind when I say space. So today's topic being satellites, I'm going to go a bit more deep dive into satellites, how it works, what are the different types, and how do we use it in a day-to-day life. Okay. So let's ask that question. What is a satellite? So a satellite is a object which is in space, which is revolving around another celestial object. It can be our moon, and it can be anything that revolves around a celestial object. And when I say that, people might have questions. So is okay. So we have our moon, which is orbiting Earth. So is Earth the satellite? Obviously, Earth is going around the sun. So Earth is a satellite of sun. People don't usually consider it. We generally say Earth is a planet, and we don't think in that scale that our Earth is going around the sun. Okay, so generally speaking, we have two different types of satellites. One is natural satellites. So, example like our moon, we have moons of Jupiter, Saturn, and a lot of different moons, or Mars. And then we have something called artificial satellites. So today's topic is about artificial satellite, and I'm going to talk about them. So artificial satellites, as the name suggests, are those satellites which are launched by humans. So it's basically man-made satellite, which is orbiting around Earth or around any planet or around the sun. So these are a few examples for an artificial satellite. So Sputnik was one of the first satellites, is the first satellite to be launched into space by Russia. And then we have Aryabhatta or International Space Station. This is all examples of artificial satellites. And the first ever satellite was launched in 1957 on October 4th. So we all know that we've been celebrating World Space Week, and this outreach program was an extension of our World Space Week activities. And this World Space Week was celebrated because of this launch of our first ever man-made satellites. Okay, so coming to satellites. So we are launching a satellite on a rocket. Everyone knows that. Now, where does the satellite go to? Right, that is an interesting question. So a satellite goes around a celestial object. I was telling you that satellite goes around a celestial object. Now, these paths are something called as orbits. An orbit is basically the path which is taken by your satellite. Every satellite goes around in a pre-designated path. It can vary from we will have different angle to depending on the Earth, or it can be from different distance. Generally the orbits starts from 160 kilometers, and it will go something like 35,000 kilometers for geostationary satellites. We will talk about them in the later stage. Now, an orbit again is a path which is taken by satellites. Now this is all we can calculate based on the time of the day and where the satellite was. We can calculate where the satellite is. Now on a later time, like on towards the end, we will do an activity where we are going to track some satellite, and then we are going to do some other activity where we are going to take some images of the satellite. Those are the few activities what we have today, and we will you also, whoever is watching now, can also easily do all these activities. Okay, let me go to the next slide. So depending on your size of the satellites, depending on the size, we can categorize the satellites based on the weight. Okay, so I will start from the bottom and we will go towards the larger one. So the smallest categories of satellites are called as femtosatellites, and it can weigh anywhere from 10 grams to 200 grams. So this category of satellites are called as a femtosatellites. Now these nowadays, with the miniaturization of electronic components, these are becoming more and more famous because it is cheaper to launch these satellites. The next is Pico satellites. These are somewhere from 100 grams to a kilogram of weight. So when I'm talking, it is based on the weight of the satellite. Okay. Then we have Nano Satellite. This category of satellites, all of you must have heard of one or the other day. They generally CubeSats. We tell them, okay, this university launched a CubeSat, this school launched a CubeSat. And these CubeSats come under this category of nano satellites, which weigh from anywhere from 1 kg to 10 kg weight. Then we have microsatellites where it is from 10 to 100 kg. Then mini satellites, they are generally from 100 to 500. And then we have medium sized satellites, which are 500 to 1000 kilograms. And the last category is called as a large satellite. So these large satellites are generally your communication satellites or your GPS satellites or weather satellites. All these satellites are generally on that range, like more than 1000 kgs. So depending on what type of satellites you use, we can use different types of rocket. You must have heard of, in Indian context, you must have heard of, we have PSLV, then we have GSLV, now we have something called SLV coming up. So these rockets are designed for specific type of satellites in mind. So let's take into the case of SLV, SSLV, the new one which is coming up. They are designed to launch mini satellites and anything below it. Like it can take up to 300 kgs of 500 kgs of payload. So it can take anything from a mini satellite and below. And we have PSLV, which can, it's a medium lift rocket and which can take satellites of up to 1400 odd kgs. And then we use GSLV for our heavier satellites. So those are like, it will be in tons, like more than 1000 kgs. Okay, so let's go to the next one. And next categorization of satellites are based on the orbits. So I was talking about the orbits, and there we have different types of satellites and different, then depending on what orbit they are going in. So we have low Earth orbit, which starts from 160 kilometers and it goes up to 2000 kilometers. And then we have medium Earth orbit or middle Earth orbit, which is generally from 2000 kilometers and it goes to 6,500 kilometers. And then we have geostationary orbit, which is at 35,000 kilometers. So these are the different types of orbits we have depending on the distance from the ground. Then we have something called as polar orbit or sun synchronous orbit. Both are basically an orbit which goes, the satellite goes from one pole to the other pole. So those are polar orbits. Then we have something called geostationary transfer orbit. These are special orbits which are used to send the satellite into geostationary orbit. So geostationary orbit is, as I said, it will be somewhere at 35,000 kilometers. We don't generally send the satellite directly there, and we use these particular orbits to save energy and send the satellite more efficiently. So these are the few different types of orbit we use. Okay, so why do we launch all these satellites, right? Why do we launch the satellites? Now, if you look at it, from the time you get up, you may not believe this, but from the time you get up and to the time you sleep, you one or the other way will be using some kind of satellite technology. It may be direct, it may be indirect. You don't really pay attention. We don't really appreciate how much satellites or satellite technology is being used on our day-to-day life. So let's look at some of the reasons why we use satellites, or why do we have satellites out there doing whatever it's doing, right? So what are the things what we do with satellites? So these are a few of the examples. So this list is not, and it's not going to end if I start making the list. These are a few of the important lists which according to me, which we use in a day-to-day life. There are more more examples I can give you, but let's look at these options. So you're making a long distance call to one of your friend in US from India. The chances are these satellite signals are going through a communication satellites, or it can also be something like an undersea cable, depending on what is the fastest route which it can take it. Generally, these goes through one of the satellites or the cables. Most of the time, it's satellite because it's faster and more efficient. That everyone loves watching TV, right? I see my mom or everyone watches sitting and watching TV. Where do the signals for this TV come from? It is coming from a satellite which is in orbiting at 35,000 kilometers from the surface of Earth, right? And then we have internet. So this is another new class of satellites We are going to talk about them again. We will talk about them. Then we have ATM. Uh, ATMs. Okay. So people may not realize. Again, this is something which people don't generally realize. You go to an ATM, right? And you put your card, you enter your PIN code, and you are asked to withdraw some money. How does the ATM machine knows it's your card? How much balance do you have? How is it communicating back to its whatever headquarters? How does it happen? People don't generally realize. But next time, I want you go when you are going out to a remote place, or when you are going out generally to withdraw money, you should see on top of the building always there will be an antenna or a dish which is sitting there, and this dish is communicating with a satellite. So that is how it is possible to withdraw money on a remotest place. Right? It doesn't require wire access, because you can just plug into a satellite antenna, and this ATM machine will work. So that is how generally an ATM machine works. So you put in your card, you enter the details, and then the machine starts sending data via satellite into the headquarters of the bank. They'll say, okay, this person is trying to withdraw some money. Should I give it or not? Then it will say, okay, yeah, this is the pin. Yeah, this pin is correct, and he has balance. So okay, dispense the cash, and that is how the cash dispenses. So once the cash dispenses, the machine says, okay, I have dispensed this much cash. Now deduct the money now. So that is how the ATM works generally in your anywhere you go. So but generally people don't realize it. Okay, next is GPS. So this is again another technology which is actively being used, right? You're booking an Ola, you're booking an Uber, or you're booking something on Swiggy to get, like you're ordering your food on Swiggy. Anything you do, how do the person who is bringing the car or you're bringing your food knows where you live, or how do you reach there? Using GPS or global positioning system. Now global positioning system is a set of satellites which are used to navigate around the earth. When it comes to, there are different types of navigation satellite. GPS is one of the navigation satellites. So we have, for India we have Navic, then we have Baidu in China, then we have GLONASS in Russia. So we have a different types of navigation satellite. GPS is one of the navigation satellite type. Generally on your phone you would find GPS, and you have GLONASS. Generally we call them GPS, but it's all navigation satellites. And then we have weather. So this is something which I do every day. The morning I'll get up, and the first thing I'll do is I'll check, okay, what are the messages I have, then what is the weather like today. So those are the two things which I'll do immediately after I get up. And how do we get that data out, right? So how the satellites basically generate the data, it's basically taking the photographs of earth. We will do an activity where we will find the weather satellite data. So we will take up the data, take the photo of the earth in a regular interval, and using that data plus the data which is collected on the ground, we can predict how the weather is going to be. And then we have digital cinema. So you may go to the movie theater and not realize this movie what you're seeing is basically being transmitted through satellites. Olden days, when I used to be a kid, so we have multiple theaters. When back in my place, we have multiple theaters around my house. And all these places, what they used to do is they used to bring a bag, like it'll be a box, metal box with the film inside, um, inside that box. That is how they used to distribute the film. So nowadays what they do is they basically distribute it through satellites. You don't need to bring the box manually. They'll just have an antenna sitting on top of your movie theater, which will be communicating with the satellites and downloading the movie from the satellite, and then display it on your theater. The last but not the least, for agriculture. So I leave that there, and let's look at a couple of how they work, or what exactly happens. We will look at those. We look at that phase now, and we will come back to agriculture later. So the one of the things which I mentioned is satellite internet, and now I am guessing all of you know Elon Musk and the company SpaceX. Now SpaceX is launching satellites called Starlinks, which is aimed to provide satellite internet. So what happens is, instead of you connecting to a router, like you connect a fiber cable to your router, instead of that, you will have a dish on top of your house, like how you have a dish for your TV. You will have a dish on top of the house, and we will use that dish to communicate with the satellite to get connected to the internet. So that is how it works. Now, Starlink is not the first company to do satellite internet. No, we had companies like Iridium, Intelsat, and a lot of different providers which used to provide satellite internet, but it was limited to corporate. Like, you're going in a flight. If you want to get connected to internet, they used to have these satellites. Now Starlink, what it is doing is it is opening that space for masses, so everyone can buy a Starlink and subscribe to their internet connection. It actually provides a lot of sense, because pulling or laying down these fiber cables on remote parts of let it not just in India, anywhere in the world, like sparsely populated places, it is very difficult and costly challenge. Now you can instead put a satellite dish and download your satellite data, connected to internet using the satellite. Now, next important thing is remote sensing data. So I was talking about agriculture and how it is being used, all those things, right? So remote sensing means taking photographs or taking data without touching. Remote sensing, that is what it means. So these satellites are equipped with multiple sensors which can take photographs. It can be radar, it can be like radio waves which will be taking images. It can be like visible range. So we have on an EM spectrum, or like you must have learned about electromagnetic spectrum, we have something called visible range. Those are the colors what we see, like yellow, red, orange, blue. All those things is what visible ranges. Then we have invisible ranges like infrared, ultraviolet, and then we have radio waves. So the satellite can use any of these to take photographs of Earth or any planet or the sea, anything. So these are called remote sensing data. Now, these remote sensing data can be used for multiple things. It is not limited to just learning about your Earth. It can be about the sea. It can be about the atmosphere. It can predict how much water content is there on the floor, or where are the fishes. All these things can be used, to like this data can be used to predict all these various things. Okay. Now next is something which I was talking about, the weather. So how do you predict weather? I gave a brief. So you take photographs of Earth. I was talking basically the remote sensing, and you take that data and use this existing data of the weather model. So they have built up the models of how the weather would look like if there we have wind in this pattern, if we have clouds on this place, and if the wind is moving this direction and this much humidity is there. All this data is there a lot. With in the case of India, we have IMD, Indian Meteorological Department. They have all this data, so they take the satellite data, then they combine it with ground data. So they have Doppler radar, something called Doppler radar. Again, this is a type of radar which uses radio waves to find out where the clouds are. And then we have sensors, like which is left in place in different places. Some places, if you go, you would have seen, like in a cage, you will have wind readings, they'll have temperature sensors, and then they have hygrometers, like basically measure the humidity. Then we have rain gauges, all these automated system which will transmit data back to the IMD. And using all this data combined, they can predict how is it going to rain now, or is it going to be sunny, is it going to be cloudy, is it going to be windy. All those things can be predicted using all these data combined. Okay, next is agriculture. So when I say, okay, we can use satellites for agriculture, you might ask, how is that possible, right? How are we going to use satellite data for agriculture purpose? There are multiple ways. Let's start with one of them. So there are companies who are doing all this. So to give you an example, so in satellite internet category only, we have a company in India. I'm talking about the context of India. So we have a company called Astro, which is trying to provide satellite-based internet. Then we have multiple companies which are using remote sensing data to predict a lot of different things, like SatSure, which is using the satellite data to see, okay, how we can grow the crops better. So this is one of the examples of how we use satellite data for agriculture. So what they do is they take the remote sensing data or the photographs of wealth and combine it with on ground readings, and we can predict, okay, how much crop yield it's going to be, how much rain it's going to be, and what type of crop would be the best for the ground, because we can read what are the minerals, we can read how much humidity is on the ground, and what would be the weather patterns which is going to come in the future. Using all this data, we can basically predict how much produce can per acre of land can make. So all these are being used now, and using that we can see, okay, this I can plant this seeds, or I can put like, okay, this particular crop would be helpful for us to make more money. Or companies who are providing insurance for the crops, we can say, okay, you pay this much of amount, we will give you insurance. So it makes it more fair. The system becomes more fair. So that is how we can use satellite. Now there are multiple examples apart from these, who how we use agriculture, I mean satellite or the space technology for agriculture. These are few examples. Now let's. I love pizza. Okay, so when I'm going somewhere, how do I find the place to, where is the next nearest Pizza Hut or Domino's? How do I find that? So for that, I can use Google Maps. And how do Google Map knows where I am? Right, Google Maps needs to know where I am. I'm in Bangalore, or I'm in this particular area in Bangalore. Google Map needs to know, right? And how do Google Map knows? That is using something called GPS or navigation satellites. Now a navigation satellites, again I was mentioning to you, a navigation satellite is a set of satellites which are orbiting Earth, used to pinpoint where exactly the person is or the user is, right? And that is what a navigation satellite is. Okay, so how a navigation satellite works is very simple. They use something called as triangulation. So generally speaking, for you or for your phone to find your accurate location, what a satellite, what your phone does is receive signals from three or more satellites which are orbiting Earth. Okay, so I'm particularly speaking about your GPS satellites, right? And these satellites are like 27 of them orbiting in the medium Earth orbit, and sending out signals telling, okay, this is the particular time, and this is the satellite name, and various other data. Now taking all this data into account, what do we do is basically calculate where the position is using triangulation, or we'll say, okay, the latency of the data reaching your device. Using that particular information, we can determine how far or where exactly you are on the surface of Earth. Okay, so that is how GPS works. Now, I've been talking about satellites, I've been talking about satellites, I've been talking about satellites. Now, there are a lot of different satellites which we have launched, right? I was telling you, 1952, we launched the first ever satellite, which is Sputnik. And we've been launching more and more satellites ever since. And these satellites also cause a lot of other problems, right? And one of the things are called space debris. Now, I was telling you, we have around 2,500 odd satellites which are operational, and we have launched more than 7,000 satellites. Some of them gets dropped back to the earth because of the earth's atmosphere causing drags. It might re-enter the atmosphere, but anything below above 500 kilometers generally don't come back to the earth. Now these are causing something called as space debris. Now all of you who are watching here, I know all of you are students. I This actually gives you a lot of opportunity, a lot of opportunity to work in the future. Space debris is a major problem which is there right now, and this actually gives you a lot of opportunities to solve this. So a space debris is anything from a paint flake to large orbiting satellites which is orbiting the earth. Okay, and these actually causes problems with existing satellites, which means it may go collide with them, or it may this small paint flake means like it may just go hit your antennas, which is going to cause problems. There are a lot of like in the case of ISS, there were certain instances where these satellites were coming too close to the ISS, which were dead satellites, which are coming too close, and the astronauts needed to take shelter inside the ISS, the safe area or the capsules, so that in case if it comes and hits, they can just come back to the Earth safely fast. No, you might have seen this movie called Gravity. If you haven't seen it, I suggest you might go see that movie today itself. There is this movie called Gravity, which depicts this particular problem which is there of space debris. So that in that particular movie, there is something called Chrysalis Syndrome, which in turn means it's a state where one satellite debris going and hitting another satellite debris, which is causing more debris, which will go hit more satellites, and it will cause more and more and more and more debris. And at the end, we will be left out with not being able to go into space because there will be a debris cloud which is orbiting Earth. So that is what this particular movie was about. It's called Chrysalis Syndrome. I would suggest you go watch that movie again. So this is one of the biggest problem we have right now, which is not yet solved. A lot of people are trying their best to come up with ideas. And if you ever have any ideas, or if you think interesting ideas, I would strongly suggest you can work on this. It's going to be one of the important things in the future. Okay, so before I go to the activity, these are some of the satellites, or two of the set of satellites which are future and interesting or important satellites which are going to launch. There are more missions, more interesting missions which are being proposed or getting ready to launch. But I find these two set of satellites to be more interesting, that you should watch out for. One is James Webb Telescope. So James Webb Telescope, you might have seen the images from Hubble Space Telescope. Hubble Space Telescope was actually a satellite which was launched into space. It's basically a big telescope which is orbiting Earth, which is taking photos of distant galaxies, distant stars, and different clusters of stars, and it have provided us with a lot of interesting insights about how the universe was formed, how the universe is outside. It is basically seeing the history of our universe because it's seeing so far away. The things which are there right now are basically like prehistoric, like when the star or when the universe was forming. That is that is kind of information we can get from Hubble Space Telescope. Now, James Webb Telescope is huge. Like it is way bigger than your Hubble Space Telescope, and we can see towards longer distance using James Webb Telescope. And this is slated to launch somewhere in end of this year. So it is supposed to be launched in December this year, and it's been postponed. Like anything, it's been delayed for almost 15 years, and it's for getting final. I remember still in my 12th, I was still talking about James Webb Telescope, how it's going to revolutionize, space or astronomy. I used to talk that when I was in 10th and 12th, and now almost 15 years, it's still being postponed. But hopefully this year it is going to be launched, and it is going to open up our eyes for like in a longer like it'll be really interesting to see what it can come up with. Okay, so let me see. Okay, so next is something called Starlink. So this is something which I spoke about extensively before some time. So Starlinks are satellites which are being launched to provide internet. They are launching new set of Starlink satellites every other week. So it is operated by SpaceX, and you can see more and more and more Starlink satellite. I think now uh, the number of Starlink satellites surpassed all the satellites launches previously held. Like that many Starlink satellites are orbiting Earth, and Elon Musk recently announced like they are going out of beta, and you can all subscribe to the Starlink internet access. Now, it may not be a problem for people who are living on the cities, but it would provide internet access for remote parts of India, remote parts of the globe. It'll be an interesting set of satellites you can watch out for. Okay, so the next part is activity time. So I'm not going to take a lot of time. I'm just going to show you a couple of things which you can use or which you can do in your home. Now there are multiple ways. So I was talking about remote sensing data. Now there are multiple ways you can access these remote sensing data on your laptop, or you can use these data to study about different places, different regions, and different things you can do with all this data. So I'm going to quickly show you two different tools, and how do you find satellite images, how do you download satellite images which are live, like as in it will be fresh data which is available to you. No, not many people know it. So let's go into that activity. So if you want to do it along with me, you can do it. The first thing what you need to do is download Google Earth Pro. So this is one of the softwares which is provided by Google. So it's called Google Earth Pro. So I'm just going to quickly open Google Earth and share my screen. So I will have my team pin these links, whichever is there to download, in the description of the video. Okay, and you can also download. So once you download and install Google Earth Pro, so this is how the world looks like. So this has a lot of features which is interesting, and you can still explore a lot of things. So to start with, before I go to whatever the activity which I was supposed to do, I can show you a couple of things if you are not if you are not used to Google Earth. First thing is you have a lot of options on the side like layers, which will actually you can check to see the borders, like you can see the weather, and you can see places. A lot of different options are there on this side. Also, you can see the roads. All those things are accessible on this side. Now, next is in Google Earth itself, you have Google Sky, which you can use to explore the stars in your sky. Okay, it's like a mini planetarium. You can see a lot of stars and planets and things. Then we have Google Mars, where you can literally explore the surface of Mars, like how you have Google Maps, you have a map of the Mars. So this is basically Mars photos which are taken by different satellites, different rovers, all are available here. The last thing is Google Moon, where you can explore Moon and its craters. You can actually see closer than how you can see on the telescope. You can actually see a different features of Moon, yeah, the places where Neil Armstrong landed, all those things you can see here. So if you can see here, there is a okay, so you can see a lot of different things. So let's get back to our topic, which is satellite data. How do we take satellite data? So here, if uh, you can see that this places where Apollo 16 was landed, and you can see like you can explore these. Okay, so but I'm gonna go back to our original topic, Earth. So let's explore Earth. So first thing I'm going to do is I'm going to search for a place. I'm going to search for Bangalore because that is where I am right now at. So I'm just going to, for the ease of it, I'm just going to open it, and like I'm just going to zoom into any place I want. I'm just going to open a random place. So this is, yeah, HAL airport. So one of the airports in Bangalore. So let's see how this particular place was transformed in the last 20 years. So that is what the first thing I'm going to do. So if you go to view and it says historical imagery, you will get a small tab here. You can use that particular tab to go and see how the place have transformed in the last, say, it has the oldest data from 1985. So you can see here it used to be like no buildings in 1985, and if you go a couple of years front, in 2000 you can see somewhat buildings. Then you go a bit more, you can see more buildings popping up, more buildings, more buildings, more buildings. You can actually see a lot of difference what is happening to the landscape. You can actually use the same data or the same Google Maps software, sorry, Google Earth software. You can use this to find out what happened to your lake or what happened to an apartment, where exactly did an apartment was built. So people who are living in an apartment, I would highly suggest you do it. You can show it to your parents also, how or where exactly did you build your apartment in? Like the company which gave you the apartment, where did it build? Did they build on top of a lake? You can just simply go here and just scroll down and just go side and see, okay, what exactly was there 20 years back, 10 years back. I'm sure most of you are school students, and you can actually see how that place where you're living was even before you were born. So in this particular case, you have imagery from 1985. So and you can go to other places where you have older imagery. So if you go here, I'm just going scrolling back to Paris, right? So it says it has imagery from 1943. So they used to take photographs of places on aeroplanes. So you have the aerial imagery of that as well. So you can see what was happening in Paris or any place in that, for that fact. You can see all that time, like what exactly happened. Now, what if you're a bit more a person who is a bit more interested in finding a latest image and using that data to find out uh, what is happening right now. So for them, you have a website called USGS Earth Explorer. Now, for that, you just need to Google uh, USGS Earth Explorer. So I'm just going to put that here. Okay, so you can see here, I'm guessing you can see here. So you can search for this particular thing in Google. You will see USGS Earth Explorer, and it will open a window, or you can open the first link, which will open this particular website. So you can see it's called Earth Explorer. So you can see here. Now, first thing is you will have to create an account. If you don't, I mean, you just need to go create an account. It is free to explore. You can download images without any prices. You can just click on create account and just give your basic information, and you can log in. Now, in India, we also have a similar website called Bhuvan, which provides the similar set of data. But for the ease of it, I'm just going to show you this particular place. So once you open your USGS Earth Explorer, it will look something like this, and you can see a world map. So once you have that world map, I'm going to go to a place where I'm very much interested in, and I'm just going to drop a pin, again a pin. I'm going to just drop multiple pins of the area which I'm interested in. So I'm just going and putting this particular area. saying, okay, I'm interested in this particular area, or I want to find out information about this area. Once you have that, then you go to data sets. Then you go to in data sets. You're going to go to Landsat, click on Landsat and open this, and then select Landsat collection 2, level 2, and then I'm going to select Landsat 8 because that is one of the newest satellite. Now Landsat 9 have launched. I'm hoping they will update with Landsat 9 imagery soon. And once I have that Landsat 8, click on results. It is going to search for the images, and once you have that, you are going to get a pop-up here, right? And it says imageries which are available. So you can see here it says 21/9/26, which was almost 2 weeks back. So you will get, depending on the area, you might get the latest images which is available with them. And you can click on this particular icon to see, okay, so this particular image covers this entire region. So in that entire region, you can see my images somewhere here. Okay. So, and if you click on this particular image, it will put that overlay on top of that frame and show, okay, this image is available. And generally what you can do is find out an image. So if it's not a time sensitive thing, you can find out an image which has less cloud coverage, right? So I can see in this we have like cloud here and there, not a lot of cloud. So what I'm going to do is I'm just going to click on download. So if you want to click on download, you have to again create an account, and then once, if I click once more, it will pop up. And for this experiment, or for this particular time, what I'm going to use is this SRB1 to SRB7 TIFF images. So I have downloaded and kept these particular images prior to this. So it is already available with me right now. So I'm going to show you those files, how it looks like. Okay, so if you download one of these files and open that, it would look something in this, something like this. So I'm just going to. Okay, so it will look something like this. It doesn't make any sense, right? It doesn't. It looks like very dark, or it's like, I don't know, it's very dark image, grayscale image. Now we have to what we need to do now is convert that particular image into something which is visible, because we want to see that image, right? So we are going to see and convert that particular image. So for that, we need a software. It's called QGIS. Okay, so we are going to you need to download, again, this link I will ask them to put on the chat or in the comments. It is called QGIS. You can install the software called QGIS. It's it is approximately 1 GB. So I'm just going to open QGIS. I already have it installed. If you don't, I mean, you can just go to their website and download. Again, I'll put the download link. Okay, so I'm just waiting for QGIS to open. Meanwhile, I'll show one more software. Okay, so meanwhile, QGIS is being opened. You can go to IMD's website. So for that, you just need to Google IMD satellite images in Google and go to the first image, and you can see something like this. So this is our Indian Meteorological Department's website, and you can see here, these are like the clouds which are coming, and you can see visible range. Then we have water vapor. You can see water vapor. Also, we have like, temperature, and then we can see animations. So there are animations, yeah. So if you click here on IR1, you can see animation of that particular place, like how the wind pattern is, how the clouds are moving, all those things you will be able to see. Okay, so these are a few things which you can see. Also, you can see here what time that particular image was taken. So it says it is taken at 6:30 to 7 something, and the dates, whatever the dates is, and the satellite name, all those information. Also, it is not just limited to India. Like you can actually see Asia, right? You can see, if you see here, you can see a larger scale, or you can see. You can explore this website. You will find a lot of different interesting images which is available here. Okay, so I have the QGIS software open now. So let me just go back to QGIS. Okay, so this is the software, how it looks like. You can, since we have a limited amount of time, I'm just going to show you something um, which is really quick. Okay, so first, okay, some moderation, it is decided that it will just pause. Give it 1 second. Okay, meanwhile, let me just quickly go to the questions what people have. Um, is there any solution for space debris created by satellites and other orbital vehicles? How a planetary defense satellite classified as? Like reusable rockets can completely reuse the satellites. Okay. So okay, let's come to the first question. Is there any solutions for space debris created by satellites and other orbital vehicles? So nowadays, I mean, there are not particular solution which is already there right now. Generally speaking, um, you can you have there are rules and regulations which are in place telling that these particular class of satellites can only stay in orbit for this particular amount of time, and generally for a CubeSat it goes around somewhere in the neighborhood of 25 years. So you have to put your satellite into orbit on that particular orbit so that we can deorbit it at that particular point of time. It is not a strict thing, but as I'm guessing, or I'm hoping that as we go on in a few years, this will be a mandatory thing that they have to deorbit these satellites in particular amount of years, because it's just taking up real estate space, like in space. And coming back to orbital vehicles, generally the fourth stage or the final stage of the rocket, if it's a Falcon 9, second stage of the Falcon 9, or in the case of PSLV, the fourth stage of PSLV, are once they launch the satellite into orbit, they will generally deorbit back to Earth. So that is how they are designed. So they will deorbit and come back to Earth. It is to prevent the space debris. So there are like options which are there in place right now, but they are not generally strict. It is in the discretion of the person who's launching the rockets. Um, but yeah, in the future you can expect more and more regulations to come on this particular area, but we don't have any solutions for the existing debris. That's what I was mentioning to you the other time. um, well, we need to come up with a solution for that. Okay, so let's come back to QGIS, and then I will, while it's processing the data, I will take up the next questions. And once you're having this software installed, so you're going to click on new. So I'm going to get a new project. So I have an empty page. Then I already have those images downloaded. So what I'm going to do is I'm going to combine all those images and make one image which is visible range. So for that, I'm going to go to raster, miscellaneous, and then I'm going to select merge. I mean, there are a lot of different options on the software. You can always explore and learn all these things. It's a free software to download, so you can always explore these things. And if enough people are interested, maybe we can make a couple of videos on how do we use this software in detail later on. Okay, so once I have that, then I'm going to select add files. Then I'm going to select files, add files. Then I know where my files are, so I'm just going to select that particular folder. folder in here, and I'm going to select that. So I have all my files here. I'm going to select all of them here, and I just added, then click OK. Then I'm going to click place each input file as a separate band that I'm selected. Then I'm going to select save as temporary file. Then what I'm going to do is click on run, which means it is going to process all those grayscale images into a visible range. So I'm just going to click on run. Okay, while it's running, I'm going to take up the next question. How are a planetary defense satellite classified as? I am mean by a planetary defense satellites. Are you talking about satellites which are like spy satellites? They are spy satellites are generally categorized as military satellites. Reusable rockets can completely reuse a satellite. Uh, okay, so so this is a question which was extension of the previous question. So like reusable rockets can be reused as completely reused as satellites. Now there were multiple experiments which happened about reusable satellites. There are there was an experiment by India called SRE. Then we had now recently, couple of months back, we had an experiment which has launched to reuse uh, so to reuse satellites or GPS or navigation satellites which are in geostationary orbit. So basically, what they did is they so there was an experiment back in couple of months back, which is attaching another small satellite into an geostationary satellite to extend the life of that particular satellite. So there are experiments like that which is happening to extend the lifespan, not to bring it back to Earth and refurbish, but it is to extend the lifespan, because geostationary satellites are generally used for communication, and these end of this lifespan is determined by how much fuel is there left on that particular satellite. Okay, so okay, it says it is uh, finished running, so I'm just going to click close. You can see that there is an image which is not so clear. That is because it haven't selected the right band. So as I was mentioning to you before, these satellites can take photographs in different bands. So we have to actually select the right band. So for that, you can actually search for whatever satellite you are using. You can search for which band pertain to which color. So in this particular case, we are using Landsat 8. So let's see what bands it have used. So it can see, you can just go here on layers and double click on merged. You can actually see that there are it says it was selected gray. Now I need to put the correct values in place. That is why that image is looking so hazy. So first thing is I need to select the red band, and red band is band 4. So I'm going to select band 4. You can easily find this particular information on the Earth Explorer website itself. You can just browse it and you can find it, or you can just search for it. You will be able to find it. And then we have green band, which is band 3. And then we have blue band, which is band 2. So I'm just going to select, click on apply. You can actually see that image have changed. Like it looks more or less like a satellite image now, like our one which you see on your Google Maps now. And after this, you can adjust these values. You can adjust these values more or less, or increase the contrast until you can find an image which is good enough for you to use it. So you can use this data in multiple ways. Because of the time constraints I have, I'm not going to go in depth, but I would suggest you explore what are the different things you can do with it. You can find the water, where are the water sources, and then use that data to find out what is happening right now, and or what has happened in the forest. You can do a lot of things with this particular data set in your hand. So I would suggest you explore what all things you can do. And okay, so with that, I'm going to end the activity, and let's come back to Kushi.
Thank you, Sujay, for your wonderful talk. I have learned many more, like a lot of facts about how to uh, search, how to see what was there on the apartment when it was like built 40 to 50 years back. I think many of us would like to see about the stories we used to tell in our hostel life, that our hostel is built on the haunted place. It's like our hostel is a haunted place, so we can confirm whether our hostel is haunted place or not.
Yeah,
So
probably.
uh, so guys, you have this opportunity which science and technology has made us, that whether our hostels are safe or not. So you can check also. Also, I would like to tell everyone that you can have many more questions that could be asked in the YouTube also, and SSERD people will reach out for your questions. I'm very grateful to our sponsors, Samarth Academy, Genex Space, and D Space.
Sir, you
Vishesh,
were Earth.
can you share the screen? Vishesh. I want to express my sincere appreciation and thank you for our sponsors, Samarth Academy, Genex Space, and D Space. Samarth Academy is one of the fastest growing edutech companies in India. Within more than 20 plus years of experience in this field, Samarth boasts of a strong presence, especially in Bangalore, the IT capital of India. Under the visionary leadership of Mrs. Sneha Hubbalikar, an expert academician, Samarth caters to the academic and extra coaching needs for kids from class 1 to 12 across all leading boards of India. Samarth focuses on coaching and guiding the young minds, mentored ably by the best teaching faculty who guide students to excel and break away from the normal stereotypical route approaching to studying. To experience best learning, Samarth offers a lot of subjective classes of your choice. So, interested people can visit The Space is an ISRO official merchandise store. To order your set of cool ISRO merchandise, visit thespace.com. Also, Genex Space is an edtech company dedicating to creating and providing high quality all around space education and services for students and institutions. Formed with the key takeaways of SSERD, a space education and outreach NGO, Genex Space is committed to igniting curiosity and preparing the young generation for this space age to solve significant challenges of our time with the help of space science and technology. We aim to educate and guide curious young minds to achieve their space dreams with space institutions, organizations, companies, startups, and professionals. Thank you, Genex Space. I would like to hand over Apurva for uh, further communication.
Sir, you were Earth and we audience were satellite in the orbit revolving around you. Thank you, Sujay, for your knowledgeable and inspiring words. We are enlightened by your talk. Students, thanks a lot for your submissions, and here is a good news and instruction for you. For the students who has not submitted their work but ready with their work can submit it now. You have 6 hours more and you need to submit them. Space travel is reaching of universe beyond the atmosphere of the earth. Guys, are you interested in traveling to space Here is the opportunity. Our tomorrow's energetic speaker, Dipti Ramesh, SSERD trainer, will take you around the space through her presentation, Journey to Space. I am super excited to attend it. And I thank all the SSERD team and Nikita ma'am for the opportunity.